Hi, this is Swapnil Bhartia and welcome to another episode of TFR Insight. And today we have with us Sam Ramji, Chief Strategy Officer at DataStax. Sam, it's been so long since we talked to each other. How are you doing?
Dude, I'm doing great, and it's great to see you again. It's been way too long.
So tell us about what are you doing these days?
So I've joined DataStax, which is a company that's built an enterprise database on Apache Cassandra. I joined a few months ago, but the really exciting thing that brought me here is to realize that Kubernetes is missing a data plane. And one of the reasons why I was missing a data plane is because scale out's really difficult. So I stumbled across this amazing opportunity to look at Cassandra as something that's already solved the scale out problem and figure out how do we marry that to Kubernetes and get it kind of into a good place in the Kubernetes ecosystem. So that's what I'm spending most of my time on these days.
You did mention that what missing, but I'm curious from your perspective, what got you excited to join the company and strategy officer? What does that mean?
That's a good question. I guess it starts a few years ago, actually. So, in 2005, I was at Microsoft and I wrote a strategy paper which said that Microsoft had to embrace open source or it was going to be irrelevant, because I had seen all of these as a service companies cropping up and they were all using the LAMP stack. And, that was not a very popular point of view to take at Microsoft at the time. But my strategy paper made it around to corporate, and I ended up getting a call from this guy, Bill Hilf, who said, "Hey, how would you like to come up and work on open source technology strategy and report out to Bill Gates?" I thought, good Lord, are you kidding me? So in 2006, I took the job, and I spent the next 3.5, 4 years working on open source technology strategy at Microsoft. I learned a lot along the way. But one of the things that really stood out in my mind towards the end of my time was we had just finished contributing to Linux. We built out all of these interoperability and virtualization drivers for Linux, libvirt contributions, bunch of driver contributions. Cloud was peaking. We're like, wow, Linux and scale out cloud is way bigger than Linux and software as a service. So that really drew my attention. Since then, I got to work at Apogee, which was focused on open APIs. Then I went to Cloud Foundry, where I got to help develop the biggest open source platforms as a service. And then I went on to Google, where they recruited me to run the Kubernetes business in late 2016. And what we saw there was this kind of neat requirement to be cloud-like, but not just stuck on one cloud. So how could you have cloud capabilities, but on your premise or any other cloud? And that was kind of the intent there. So I got to work on Kubernetes, all the Kubernetes CI/CD, Cloud DevOps, a whole bunch of stuff built around that. And then I left Google and worked at Autodesk for about 15 months, where I was the head of the cloud platform team. So Autodesk gave me about 1,000 engineers, had about $180 million budget, spent $60 million of that on Amazon as we were becoming a cloud company and focusing on data. So all of that kind of combines and bring me to realize, wow, the hard part of this that is really not solved is data. We figured out how to do scale out compute, and that's built on top of scale out networking, which we take for granted. But nobody's really nailed the scale out data component. And we ran a 5 petabyte Cassandra infrastructure at Autodesk, which was growing by leaps and bounds, 800 nodes or so, building out a capability to store the world's manufacturing data that people were building in Autodesk software. But that was so hard. So when I came across Cassandra and DataStax as an opportunity to go bring to the cloud native world, I thought this is just so obviously the opportunity of a lifetime to understand data better, to be able to serve the community by linking a really well-proved open source database with really well-proved open source cloud native technology. Like, it just made sense.
And since you are, Chief Strategy Officer, what is the strategy that you have for this year?
Sure. So Chet Kapoor, who was the CEO of Google, of Apogee, and was an executive at Google, and Ed Anuff, we also worked at Apogee together, and he was an executive at Google. The three of us all talked about this opportunity in sort of late fall of last year, and we decided that as a group, we were all going to join and bring to life this new strategy, which I'm going to tell you about. So there are 3 really simple pillars: open source, scale out, and cloud native. So that first piece is to restore the vibrancy of Cassandra as an open source community. there was some scattering that happened in 2016 as different parties were pulling on different requirements for Cassandra. And as an engineering community, we couldn't figure out how to make all those things work together, right? So you saw Netflix and Instagram and Apple and DataStax and others go in different directions. So that kind of scattered the tribes. Right now, we're trying to gather the tribes back together. Apple's leading the way to get a Cassandra 4.0 release this year. We'll probably see the beta in Q2, and we'll see the GA later this year. For all of us as innovators and contributors to come together and say, what have we learned about Cassandra in the intervening 3-4 years? And how can we start to have an architecture that sets us up for cloud native? That second piece, scale out. We have to be super clear that there are a ton of NoSQL databases out there. So when there's a ton of things out there, you got to know what makes you special. Cassandra was invented at Facebook by a set of Facebook engineers trying to figure out a global spanning database strategy and how to do that in a way that would work technically and economically. So scale out is kind of the core of what Cassandra is really meant for. And that's what it's been pushed on for a decade. So it's hardened to do not just lots of nodes in a cluster, lots of clusters in a multi-cluster, lots of clusters in multiple regions, all as one addressable data fabric. So that's what it's really good at. Delivering on that, we have an enterprise database, and we'll continue to release on-premises enterprise databases. But the big stretch now is to go to the third pillar, cloud native. So what's great about cloud native is you've got that cloud native ability to be hybrid or multi-cloud, to be on top of scale out networking, scale out compute. But what's tricky about cloud native is what do you do with the data? So it's missing a data plane. You typically provision one data service into a cloud native environment, or 2 or 3 services. But those all share the same challenge, which is unlike a cloud native environment, which scales out and scales in, a little bit like breathing, right? When your application workload spikes, you want to grab more capacity. And then when that spike is over, you want to exhale and let it go. The database tier doesn't really do that today. We still provision the data tier to peak. That's kind of tough because it's not releasing resources. So to be able to get a proper cloud native database, you want something that will ride along with Kubernetes, that will ride along with Istio, that will ride along with Envoy, that will ride along with Prometheus, and expand and contract and fit the application workload that's being directed through Kubernetes. So that's a super interesting area. And what we're doing there this year is releasing Kubernetes Operator, a management API representing a bunch of management capability for Cassandra, and working to develop that in collaboration with a bunch of like-minded engineers. So it turns out ours will be like the 8th or 9th Kubernetes operator for Cassandra. We actually think that's great because all of these different companies, whether it's Netflix or Sky or Orange, have all figured out different ways to do a Cassandra operator that fits their specific environment. But being able to partner with them and be able to partner with Instacluster, right, that builds a cloud scaling Cassandra environment so that we can all put our best general ideas about how Cassandra and Kube is like peanut butter and chocolate, right? How is this kind of the perfect pairing of data and compute for a cloud native world? That's where we want to go. So open source, scale out, cloud native, those are 3 very core strategy pillars. And everything that you see from us, everything that we release, everything we work on with anybody, anything you hear us say, it will relate to one of those 3 things, right? So we've got clarity that they all build together. No open source, you don't have the right to be in business. If it doesn't scale out, you're not an interesting, different database without cloud native. You're kind of missing out on the big future opportunity to participate in the biggest change and growth that I think we see in the industry.
And if you look at Cassandra, it's kind of predates all these buzzwords or like paradigms. We talk about cloud native and microservice like 207, 208. That's when the project came out. So if you look at the evolution of the project, what makes this project kind of uniquely suited for these kind of cloud native data on Kubernetes?
Yeah, I think that really falls down into 2 areas. One is how do applications experience Cassandra? And then the other one is how does Cassandra scale? So how do applications experience Cassandra? Once you've written your application and talked to Cassandra, you never have to change how you talk to Cassandra. If you're talking to a relational database, right, or you're talking to a less scalable database, you're always going to end up in a state of needing to shard the data. Now, that sounds fine to the average user, but really it's a huge cyclical burden for the entire system. So if you look at the DevOps or the CI/CD environments that we have, anytime you make a change, you need to update and test the entire system. So when you scale up an application to the point where one database isn't going to cover your needs, you shard it. And you typically come up with some kind of strategy for sharding. Like the trivial one that they use in teaching is, okay, let's say you've got a database of all of your customers. It's all sorted by last name. Once you can't put them in one database anymore and you have to have two, you'll say, well, A through M, that's going to go in database A. N through Z, that goes into database B. That's all well and good. But every application that talks to that database now needs to change its logic because the sharding logic ends up living in the application stub. It's got to know to call a different database. That's tricky. So Cassandra is shardless. That's pretty interesting. The second half is all about how Cassandra manages to be shardless. Its ability to scale out is based on its masterless or multi-master architecture. There's no single point of failure. There's no one version that is getting replicated by all the others in chains. It's more like a ring, right? All these things are meshed together and they keep talking to each other. They update each other over time. And so your ability to scale Cassandra from a few nodes to many nodes, from one cluster to multiple clusters, from multiple clusters to multiple regions, that's all tested and proved and built in, because that was exactly the problem that Cassandra was built to solve for Facebook in the first place. So as we look at how these things now have evolved in internet scale companies, cloud first companies like Netflix, like Apple, like Instagram, you can see that these things are incredibly beneficial to global companies like Federal Express, like Verizon, like JP Morgan Chase, that are trying to get those same capabilities. Even though their primary business is not internet services, they need that same internet scale in order to get the service tone that all of their users expect. And we think that, as the world gets more intensively digitized, that's maybe the silver lining for COVID, is that we're all having all these conversations remotely, that going digital has gotten to be a critical priority. You got to get there faster. So everybody's looking for help. So I think that's a multiplier effect on being able to serve all of these communities by getting them a cloud native environment that supports compute and data. Because without compute, the data doesn't matter. Without data, the compute's useless. So we want to bring those together.
Now let's talk about Kubernetes a bit. What kind of trends are you seeing in the Kubernetes ecosystem in context of data management and stateful application today? Actually, everybody's using it. It's not the question who is using it. So, well, who's not using it and why? So talk about those trends a bit.
So one of the trends that we've seen in the last year, which has accelerated, is that Kubernetes has won. It is the de facto standard for container management. When you and I were chatting more frequently back in the good old days at Cloud Foundry, and I look forward to more frequent conversations now that I'm at DataStax, it was unclear whether like runc or containerd or Docker would be kind of like the standard, whether Swarm or Cloud Foundry or Kubernetes or Mesos or some other homegrown, management environment was going to do the container orchestration. We didn't know. It was 2015. But now it's 2020. And the acceleration of Kubernetes as the standard has now gotten to the point where, I think it was IDC measured this recently, of all of the enterprises worldwide that are doing container orchestration in production this year, 87% of them are using Kubernetes. Now that's shocking, because like a year ago it was like 50%, a year before that it was like 20%, so the growth has been really fast, and it has actually displaced using Mesos or Swarm or other technologies for doing that. So I think that's the biggest trend, is that you don't have to wonder, you don't have to argue, you don't have to research, you don't have to stress anymore, like it's Kubernetes. That's the biggest trend. Trends for Kubernetes on data are a lot harder to see, because mostly the big movement with Kubernetes is the standardization of workflow in application development. So CI/CD, DevOps really depends on having consistency in your development, packaging, testing, deployment plane. So if you look at the last KubeCon, most of the announcements, most of the presence there was all about CI/CD on Kubernetes, because that's a really good place to solve that problem. At the same time, most of that movement is all about CI/CD workloads and how do you make sure that development's happening, testing's happening, security and securability is happening. But there's very limited offerings for data, which is kind of interesting, right? There's a project called Rook, right? There's the Open Service Broker API. There's ways to poke a tier up into Kubernetes to make it kube addressable, right? But that's not the same as having a data plane for kube that just scales out and works the same way. So there's a lot to learn here. No doubt I'm ignorant of some activities that are happening in data in Kubernetes, and hopefully talking with you in this video will help me learn more about it, because people will be like, oh, you're such a fool. There's these 8 wonderful ways to do data in Kubernetes. What are you doing strategy? And I'll say, great, tell me about it. I'm really curious.
You guys are also releasing a new Kubernetes operator for Cassandra, if I'm not wrong. So first of all, who is it for? And what does an kind of operator do? And how do you differentiate it from other operators that are already there?
Great questions. I'm going to tackle those in reverse order, because differentiation is a word that I'm trying to get DataStax to let go of. I actually don't think differentiation versus open source or open source communities is a sensible thing. Right? What we want to do is to be able to we want to collaborate, and then we want to figure out where do we add value. So when we release this as open source, it's intended as a reference of our opinion about how Kubernetes operators can work for Cassandra. It's going to be the 8th or 9th kube operator that exists for Cassandra, and I think that makes good sense. Most of the operators have been written by one company to solve their problem of operating Cassandra at scale in their environment automatically. So each environment has got its own very specific needs and requirements. Which logging system are you using, which manageability system are you using, which graphing system are you using. All those things are specific to each environment. So each of these operators has been built by people who are stress testing, right, and building good quality software that fits their environment. So that's how we learn the specifics of the needs of Cassandra and Kube. What we have to do, because we're a commercial provider of an open source project, we have to go towards generalization. And sort of generalization and specificity exist in kind of this dynamic harmony. What we're going to offer is going to be the generalization. Others will say, hey, that's great, or that's terrible, right? That fits my environment, but that misses my environment these other ways. And that should be a conversation that we all get to have as developers together. So in an ideal world, 6 months, 12 months, 18 months from now, all those different opinions start to look more like each other. And really, who cares who wrote the kube operator for Cassandra that becomes the most popular? I certainly don't care. What I care about is that as a user, somebody can come to the Cassandra project and say, that's really cool. I need that to work with kube. How do I do that? They get a really obvious answer and they go, that's the kube operator for Cassandra. They grab both, they install it in their environment, and away they go with scalable data. So it's an invitation, right, for the whole community to participate and build towards a great common operator. One of the things that is really important that we're launching alongside is we've learned a lot about what it means to manage Cassandra in an operational environment. That's both from our core commercial business, where we have an enterprise distribution of Cassandra, DataStax Enterprise, scaling in these environments, like I mentioned, like Federal Express or like Verizon, like JP Morgan Chase. There's a bunch of stuff that we've noticed that Cassandra doesn't have by itself, that it needs some logic to be operable. We've also learned a lot from hosting Cassandra in our own cloud. We have a cloud offering called Astra. So what we've learned to scale Cassandra, we've isolated into what we call a management API. So we're offering the management API, which is obviously invocable, but it's got a bunch of logic that is custom to Cassandra, that works with Apache Cassandra, as you'll find it in the public repositories. That's an important component to make Cassandra more operable. So we're releasing the management API for open source Cassandra, and we're also releasing the Kubernetes operator for Apache Cassandra as an opinion that we're sharing with the world. Our technology will run on the open source operator as well, right? So whether that's our Astra cloud service or whether it's our on-premises enterprise database. But this is us kind of defragmenting a bunch of different engineering efforts and then working openly with the community to say, like, what do you think of this? And frankly, the core of the open source strategy is whatever we end up agreeing on as a community, that will be our product roadmap. We'll follow that, because if you're not working with the community, you're not creating a great ecosystem. You're not creating a great opportunity for yourself commercially. So whatever it is that people end up settling on, that's what we'll move to adopt. But you got to start somewhere, right? Which is why we're putting our offering out there, our skin in the game, so to speak.
If you don't want to differentiate, if like an open source project, it doesn't really matter. And that's also actually critical, because sometimes you get the same open source project from a foundation or organization, but different vendors take it and then they differentiate it and it becomes interoperable, or you cannot move from one vendor to the other. So it becomes, with open source, you create vendor locks. So I want to hear your opinion on that. How should companies or, communities you do need to have some edge over others so that you can attract customers, but you should not, differentiate. So can you talk about that a bit? Because I really like what you said there.
Yeah, I'll make that really practical, right? We can talk about this theoretically, and I'll offer like a theoretical frame. But again, we always care about practice more than theory, and I think we should, because that's where the proof is. So I think the theory here is Tim O'Reilly, I think, really put this best, and I heard him say this first in 2008. He probably talked about it before that. He talked about an architecture of participation. And he used that to talk about open source, and he used it to talk about the internet. Right? With the internet, he also talked about many pieces, small pieces loosely joined. But this architecture of participation is something that I've taken with me from those first interactions with Tim. If you have an open source project that's just like one monolithic blob, that's not really architected for participation, right? Participation is an intent. If you want something to be like super fast and really easy to deploy, and like there's certain affordances, maybe the best way to do that is one giant blob of code. But if you want to be able to onboard new developers, if you want to be able to change how the system works without having to fork, that requires some real intent, right? So think about Linux early on versus what it became subsequently, right? You look at, where did Linus put his effort versus where did Greg Crowe-Hartman put his, right? And so the Linux kernel driver project and the modularity and pluggability of that architecture of participation, that's by far the largest code base in Linux, right? So that was very thoughtfully architected for participation. Now today, Cassandra looks a little bit more like a monolith than it does like something that's carefully architected for participation. So what I believe we need to do, what I've been saying internally, what I've been saying externally, is there's really three different places that we need to shift our architecture. One, the developer experience. To your point about lock-in usually happens at the application layer. Like if you think you've got an Oracle application, it's probably because you're writing the Oracle features and the Oracle implementation of SQL, right? And then your ability to move off of that is restricted because you're kind of tied down to the Oracle version. So what does that look like? In Cassandra, over the last few years, we've evolved something called CQL, right? The Cassandra query language. That's one opinion about an API for this. But there's others, right? So you look at what does a time series database front end look like? What does a graph database front end look like? How about gRPC? How about GraphQL? So there's a set of affordances, right, at that layer that need to be built intentionally. You got to be able to plug new things in. What's the most popular data API going to be in 5 years? I have no idea. And anybody who does is either from the future, confusing themselves, or selling you something. So that layer of the architecture has got to have pluggable APIs, right? What's beyond graph? Who knows, right? But whatever that is, it should be plugged in there. And that should release some of the pressure of lock-in, right? Standardizing developer APIs. I think there's another side of this, which is what's the operator experience? You think about the command line interface, or some of the automation targets that an operator is going to write against, right? Your operational stance is another really important area that changes over time. You remember Hyperic, right? And Cigar, right? The interface that Javier Soltero and his team built back then. That was really hot in 2006, 2007. Is it still being used? I don't really know. I'm not close enough to it, but just an example that these things kind of move over time. So you want to be able to have some flexibility there. And then finally, for a database, the storage engine interface needs to be designed. And that's one of the most interesting areas I think that we'll see in 2020 getting attention in Cassandra, is there's so much advancement happening in storage networking, in network block storage, large-scale environments for AI, for ML, as well as for just mainstream deployment of large-scale applications. Right now, we have Cassandra with its own storage engine. Then you've got Instagram that built Roxandra, which is Cassandra forked writing against RocksDB. Now, Amazon said, wow, that's pretty interesting. We're thinking about using the Cassandra front end against the Amazon backend, the AWS backend. So they started with, as I understand it, the Instagram fork, and took that further and forked it again to talk to the DynamoDB backend. Now you've got this sort of Cassandra Dynamo hybrid that's AWS managed Cassandra services. Now, forking to change, we saw this in Cloud Foundry, right? You had to fork Bosch in order to add new cloud providers. So what we started to realize is that bottom engine where your fabric or your platform is talking to like reality, forkability is not as good as pluggability. So in Cloud Foundry, we established what was called the CPI, or the Cloud Provider Interface, and we moved towards making that pluggable so you can plug different things in. They can evolve at different speeds. They can be built by different vendors who really understand their own infrastructure. I think as we build the storage engine interface as part of the architecture for participation for Cassandra, we will see a lot more different experts and companies come to bear so that we can plug into all of their differentiated, awesome environments.
How important open source is for DataStax, and how are you, what I mean by you, I mean the company, either involved with these projects like Cassandra or contributing to them? Can you talk about that?
Sure. Yeah. So I have the pleasure to have a very small team at DataStax, just a small strategy group. There's 3 of us, but the strategy has been well enough adopted that we allocated about 25 engineers to work on nothing but open source. So that seems maybe obvious in hindsight, but in terms of putting our shoulder to the wheel to make sure that the 4.0 release comes out this year, those engineers are, writing documentation, they're documenting code, they're closing Jira tickets, right? They're doing all of the kind of, greasy work that nobody really enjoys doing, but somebody's got to do. So partnering with the 4.0 community, obviously led by Apple with all their great advances on testability and reliability to make that real. So there's a reason for that, because engineers clearly are pretty much the most vital asset in any software company. For us to allocate such a high percentage of our engineering force, I think that's about a quarter of our engineering team at this point. So that tells you that strategically it's absolutely vital. Now, why is it vital? Well, the other part of my job is to make it all work for the business, right? So we're in an amazingly fortunate spot where NoSQL as a market is expanding very, very fast, right? So just 2 years ago, it was about a $4 billion market. Now, how we measure markets, again, if you're not like a marketing nerd, remember that I'm an engineer. I started as an engineer, but I took a long journey through marketing and business development to understand how this stuff works. Trust me, it's all math and engineering at the bottom. Anybody can understand any of this. The way that people measure markets is they say, like, what's every dollar that goes into using the technology, sourcing the technology, maintaining the technology, ensuring the technology per year. So no one vendor is taking a big chunk of a multi-billion-dollar market in general that looks at the salaries of full-time employees of companies using the technology, right? Particularly as you look at open source, right? It gets very interesting. It's all the professional services companies. It's also vendors. It's also hardware providers often. So in a nutshell, NoSQL a couple of years ago was about $4 billion. Last year, $6.5 billion. And IDC, which is the best company that we have in the industry for measuring growth rates of markets that are this big, says it's growing at about 35%, 34% a year for the next few years. Now you think about that kind of growth. The rule of 70 says divide 70 by your interest rate, and that's how fast it'll double. So 34% is about half of 70. So that means it's doubling every 2 years. So by 2023, we think NoSQL as a market is about $21-22 billion. That is astronomical growth. Now, we're sitting in privileged company there along with Databricks and Confluent and Mongo and Kafka. We crossed a very, very important boundary for software startups. Recently, we crossed the $100 million barrier. So once you're generating 100 million in revenue per year, that's pretty substantial. Now, you can get there with a bunch of different tactics. And the next thing that you try to do is, how do you get to $1 billion? To really see the path to 10x growth, right, to $1 billion in revenue, you have to see a positive, popular, quickly expanding project. People have got to be succeeding with it. They've got to be talking about it positively. They've got to be doing that openly. So I don't see a coherent way for an infrastructure company in 2020 to grow rapidly to those kinds of scales without doing an amazing job of taking care of and participating with the community and really making sure that the rising tide lifts all boats. One of the things that Bill Gates used to say was that the thing that made Microsoft effective, right, successful and profitable was that it made money for everybody else. So when we made $60 billion in revenue at Microsoft in 2009, the ecosystem made $450 billion. So if you're doing this right, you're kind of at the bottom of this pyramid and you're supporting way more people generating way more money than you. As a software company, you build a really efficient engine so you can make your money with not that many employees. But the ethics of this, the aesthetics of it are that a lot of people are succeeding in order for you to have a place in the world. So that's a little bit about how I think about it. That's how DataStax is coming at it, right? I just think like no open source, no option. Right? There's no business in infrastructure if you're not driving open source.
Before we wrap this up, you did talk about it initially when we talk about your strategy for 2020, but in general, what can we expect from DataStax this year? What are the things that you guys are planning? Whatever you can disclose at this point.
So it'll go back to open source, working super hard with the Apache Cassandra community to get 4.0 out, to get the beta out in Q2, and to be able to get the GA out in the second half of the year. That's super important. Scale out, right? Making sure that the large enterprises that are succeeding with Cassandra continue to succeed given the enormous additional market pressure and interactions that they're getting as the world goes digital really fast this year. And that's with our core database product, DataStax Enterprise, which is built on Apache Cassandra. And then cloud native, right? So learning from what we understand from Astra, our cloud service, but participating really, really well, right? There's almost got to be an open source attitude to how we engage cloud native, because that's going not just with other Apache Cassandra experts, companies who are also commercial providers like ScyllaDB or like Instacluster, as well as professional hosters and people building these things at scale like Orange Telecom or Sky Broadcasting, or any of these other folks, but reaching even more broadly to the cloud native community. How do we learn more as a development community in Cassandra about Kubernetes? How do we make these things come together, right? Because they haven't been together historically. And the better that they understand each other, right? The better that the developers working on or around Cassandra understand Prometheus and understand Istio and understand Envoy, as well as Kubernetes and the whole shooting match. That's a big set of steps for us to climb together, right? So whether that's the Kubernetes operator or the machine, or the management API, anything along those lines, we'll be pushing forward on that. So I think those are the things that you can expect. Anything that finds a home in either making Cassandra better, faster, easier to use, easier to operate in cloud native, or more secure and scalable for enterprises. Those are the things that we're shipping. Pretty soon we'll release the next version of our DataStax Enterprise 6.8. Got a bunch of cool new workloads in it, a very powerful graph database, full text search, and then the ability to work on top of Kubernetes. So all those things are hopefully coherent, open source, scale out, cloud native.
Open source has always been decentralized. People have been working remotely already. They do. So how does this crisis either make us kind of be aware of it, or how does it also allow us to bring all those experiences, expertise that we have gained and help people?
Yeah, that's an awesome question. So much of what we're about as a community in open source is about sharing our ideas and sharing our strength. And so the things that I'm focused on right now is we've just launched a new free support, basically gift to the world. We call it "Keep Calm and Cassandra On," because we've had the good fortune of building a strong business and learning a lot about how to scale Cassandra and keep it operating. So for the duration of the crisis, we're offering free SRE to SRE support. You can get on, you can get on a call. You can get office hours. You can get text, text support, whatever format you're most comfortable with, to figure out, like, how do I troubleshoot my Apache Cassandra installation? Like, it doesn't matter if you pay us money ever before or ever in the future. We just want you to succeed with Apache Cassandra. So that's our skin in the game, right? Is keep calm and Cassandra on. What I'm seeing that's really cool is we and a lot of other companies have the benefit of having commercialized an open source project, right? So when you look at Jonathan Ellis and the other folks who kind of kicked off the growth of the Cassandra community a decade ago, right? Those contributors live everywhere. And so DataStax is a distributed company. We say that we're a distributed company that builds a distributed database. So, we don't call it remote, we call it distributed. It's a different way of looking at it, right? Remote seems like a second-class citizen. Distributed is kind of like by design. We are trying not to beat our chest and say oh, we know so much about remote work. We're just it's just kind of what we do. So I'm seeing people in the community talking to each other. How do you fix this? How do you get better at that? I've seen a lot of really nice blogs from open source developers and communities from a range of different technology projects talking about the realities of remote work. What does it mean to have your dog hop on the camera? What does it mean to keep yourself motivated when you're starting to feel socially isolated? So I think there's a whole social fabric, right, that's been built in open source for the last couple decades about how to do that.
That's true. And once again, Sam, thank you for taking your time out. But as we discussed, we're going to see more of each other, and I would love to continue this discussion and talk to you on a regular basis. Thank you.
Me too. Swapnil, thank you so much. It's a privilege to be on your show, and thank you for the service you're providing. I know a lot of people are going to be, feeling bored and lonely and needing something to take their mind off of the current events, and I know they're going to turn to you to find out what's going on. So thanks for the time, man.